Go.
Great. Okay, so we did this. Remember, this is called, x is called position. Delta x is displacement. It doesn't tell you how you got there, how much distance you had to travel to get there, how many turns you took or anything back and forth. Let's take another look. And now let's do 2 dimensions. Just a real quick intro to this. You'll get used to it, so let's not try to do too much right now. But we'll build up on a good, strong notation that's going to help you. It's your little cheat sheet as you go. So you can remember and connect what the math means to your picture, which connects to the physical process we're talking about. So let's imagine our object, anything. It could be a ball, it could be anything. But you can have fun drawing more complicated pictures, but, and if it's fun, that's fine. But let's keep it simple too. So let's say I have a kind of a standard coordinate system. Let's do it this way. Let's do it this way. I'll make my x, and I think I'll go ahead and use blue for the whole thing. And y, or x, this will be, let's call this x, and let's just go ahead and say meters, and y. So x, y, and z for position. We won't do 3 dimensions. And then let me just write that. So that's going to be somewhere over here. Its position at state 1 is there. And I need to write, let's just say that's 1 meter, 2 meters, 3, 4, 5, 6, 7. And then I'll go over here, try to keep it kind of nice. 1, 2, 3, 4, 5, 6, 7. So there's position 1. Put a 1 in there. 1. That's where it is now, earlier. And I would say that its position with this coordinate system, x1, y1, is equal to, let's see, x is 1, 2, 3, 4, 5, 6, negative 7 meters. Just hang with me, even if you get it, you'll see that there's a point where it's interesting. And then plus 2 meters is y1. I'm just making it up, just so we can see a difference. And let's just say that I go like this, and I'm going to want to think of my coordinate system like a grid. This is going to come in real useful, this idea of a grid, when we do vectors. So believe me, we are building up to the good stuff. So somehow I got this like graph paper. Something like that, crazy. But I could talk about it using any coordinate system I want. Again, I can switch up. So I can make, I could make this, let's do it here. And let's call this the positive x still. Let's call, that's my origin. And I'm going to call this the plus y down. I'm going to flip it. Okay, so how many is it over? Using this, I'm going to try to use it kind of easy. 1, 2, 3, 4, 5, 6, 8, 9, 10. So there I go here, and I can say down here, x1 red or prime, y1 red or prime is equal to 1, 2, 3 positive plus 3 meters, because I'm still calling that plus. And then I'm calling this plus, so 1, 2, 3, 4, negative let's see. Can I call that -1, -2, -3? Not so great. -4, negative. So then this, because that's plus, -3. It says meters there, so I don't really have to write meters there. So I'm at -3 meters in the y direction. So watch how this works out real quick. And then it does something. Who knows? But the cool thing is, like if I go like this, and I end up here, no, I don't want to end up there, it's too hard. I want to end up, let's end up here. Okay, so that's 2. Whether I take some weird path or I just go straight there, I still have the same displacement. I started at the same place, I ended at the same place. So displacement means I've got to subtract these. x2, y2. I just got to do this. We're not going to do a ton of this, but a little bit. Let's see, let's see, there's my origin. X2 is -1. Y2 is 1, 2, 3. Okay, there and there. X2 is -1 meter, and Y2 is 1, 2, 3 plus 3 meters. It's all about the details and going slowly enough so that then it comes out nicely. I guess we might as well do X2 prime, Y2 prime. It's just a notation. You can make, there's other notations. For my red system, I'm 1, 2, 3, 4, 5, 6, 7, 8, 9. In the positive, plus 9 meters. And then the y, I got to go up. 1, 2, 3, 4, but that's negative. It's really, you see this, just so easy. There's so many puzzle pieces. But little by little, it comes together. You don't do it all in one step anymore. And so let's calculate it. Delta x, the displacement in the x direction from 1 to 2, is x2 minus x1. I just look up here. I can't memorize all this. I got to just be careful. -1 meters minus, so that's x2, x1, oh, minus 7. I recommend doing that. It's so easy to make a mistake. Minus x1. So that's -1 meters plus 8 meters equals plus 7 meters. 1, 2, 3, 4, 5, 6. What did I do? Did I do something wrong? Oh. See? And so when you make a mistake, you can always figure it out. You're going to make a mistake. You know, someone calls you on the phone, whatever. You go, oh, and sometimes it's easy. Sometimes it's a negative sign. That's not plus, that's plus 7. Oh, 7, oh, that's 6. And then I check it again, and this is how we do it. So we're bouncing around like I do. 1, 2, 3, 4, 5, 6, that way. Doing chapter 5 already. Which I call plus direction 5 meters, oops, 6 meters. Yes, it makes sense. It's slow, but this is how we do a lot of stuff. It's great. And then what did I go up? I know I can see from here I went up, which I call plus 1 meter. Let's see if that works out. Delta y 1 to 2 is y2 minus. So it gets intimidated, like, because we're used to doing some things in our head. You can't. Y, I got to look at what I wrote down. Y2 is 3 meters minus y1 is 2 meters. That's plus 1 meters. Yeah. Cool. That worked. And then to finish this off, you do the same over here. I should probably let you do that. I should let you. So delta x prime 1 to 2 is equal to, and delta y prime 1 to 2 is equal to. And what you're going to find is you get the same amount. For x, they're both positive this way, so they're both going to be positive 6. For the blue, up is positive. For the red, up is negative. So you're going to get negative 1 meter for the red. So check that. That gives you as much as you need. That's a lot for position and displacement. And distance, there's not often an easy way. You just have to look at it. Now, I got to know the path. That's how many steps I took along the path. And I could have taken many different paths to get from 1 to 2. And don't worry about it. That'll just come as the examples come. So now we'll deal with velocity and acceleration.